All right, here's a theorem of utmost theoretical importance. It's called the mean value theorem. And what it says is that if you've got a continuous function on a closed interval and that same function is also differentiable on the same open interval, then somewhere the slope of the tangent line has got to be equal to the slope of the secant. Here's what I mean by that. So here's it stated more precisely. So if f is continuous on the closed interval from a to b and differentiable on the open interval from a to b, then there is some number c in the open interval from a to b such that the instantaneous rate of change of f at c is equal to the average rate of change of f on the interval from a to b. In other words, there is a number c in a to b such that f prime of c is equal to f of b minus f of a over b minus a. So remember, derivative means instantaneous rate of change. This is just the old formula for the slope of the secant line, or the average rate of change. So we're saying that the slope of the tangent line must be equal to the slope of the secant line. So here's a picture. Here's a function that's smooth and continuous on the closed interval from a to b, differentiable on the open interval from a to b. Right, maybe there's a vertical tangent line here at x equals a, so it's not quite differentiable on the closed interval from a to b anyway. But if you look at the slope of the secant line, right, here's the slope of the secant line. Somewhere in there we can draw tangent lines that are parallel to the slope of the secant line. So here's one place where we get a parallel tangent line, and so that happens at a point, let's call it C1. So here's a number C1 satisfying the conclusion of the mean value theorem, right? And it's in the open interval from a to b. The mean value theorem guarantees the existence of at least one. There might be more. Here we can see that there is another spot where the tangent line, the slope of the tangent line is equal to the slope of the secant line. So here's another point, C2, in the open interval from a to b that satisfies the conclusion of the mean value theorem. So mean value theorem says that the slope of the tangent line, somewhere there's a tangent line whose slope is equal to the slope of the secant line on the interval from a to b. Okay, let's look at another quick example. We want to find a number c satisfying the conclusion of the mean value theorem where the function is f of x equals square root x, and the closed bounded interval here is from 1 to 9. So certainly the square root of x, here that thing is continuous everywhere on its domain. In particular, it's continuous on the closed interval from 1 to 9. It's differentiable on the closed interval from 1 to 9, but it's certainly differentiable on the open interval from 1 to 9. And so all we are saying, the mean value theorem says that if I draw a line connecting these two dots, right, from 1 to 9, then somewhere in here I can find a tangent line that's going to be parallel to the secant line. So I'm basically looking for this number c. So we just need to find the average rate of change of this function on this interval, and then find the instantaneous rate of change, or at least an expression for the derivative, and then set some things equal and see what happens. Let's compute the average rate of change of the function square root x on the interval from 1 to 9. So the average rate of change, remember, that's just f of 9 minus f of 1 over 9 minus 1. What's f? It's the square root of x. And so I get square root 9 minus square root 1 over 8. This is 3, this is 1, and so I get 2 over 8, which is 1/4. So my average rate of change is 1/4. So I need to know where the instantaneous rate of change is equal to 1/4. In other words, I need to know where the derivative of the function is equal to 1/4. Well, here's the derivative. It's 1 over 2 square root x. And so I need to find a c that when I plug that thing into the derivative, I'm going to get 1/4. So just take 1 over 2 square root c and set it equal to 1/4. Solve for c any way you want to, or you can just eyeball it. And that tells you that c is equal to 4. So there's the point at which the slope of the tangent line to the curve at the point x equals 4 is equal to the slope of the secant line connecting the two endpoints of the graph on the closed interval from 1 to 9.